Hi, I'm Chem's best friend. I make chemistry easy. I'm a graduate of MIT, and I have more than 17 years of experience teaching AP chemistry and chemistry classes. Please like and subscribe to my channel. And if you are interested in private tutoring lessons, the information is on the screen. Hi, today we're going to learn how to count atoms using moles. Well, how are we going to do that? What is a mole? A mole is a cute little furry animal that lives in the ground, and yet we're going to use it to count atoms. Let's figure out how to do that. So let's go to my screen. A mole is also a number in chemistry. It is a very, very big number. It is 6.022 times 10 to the 23rd power. It doesn't have a unit. It is anything you want. So we're just going to say any units. Think of a mole as a dozen. If we are going to go into a business of selling eggs, we would be packaging these eggs by dozens. And you know that a dozen means 12. So if I tell you that we sold 40 dozen eggs, you know that we sold 40 times 12 eggs. Why don't we have to use a mole to count atoms? Atoms are so very, very, very small that we cannot package them in dozens. We're going to package them in moles. And it's again, this number, 6.022 times 10 to the 23. It is more than the stars in a whole universe. It's a huge number because atoms are so very, very small. And here is the mole. It actually is very, very nice that we use moles because they dig tunnels. They go from point A to point B. And we're going to come back to that. So let's count atoms of copper. We're going to make two columns. In the first column, we're going to write our number of atoms. It's going to be right here. And over here, we're going to put the mass of these atoms. Now, we're going to look at our periodic table. Copper is right here. And we can see that the mass of copper is 63.55. But what do I mean, mass of copper? Well, we can look at our periodic table and we can say 1 atom of copper is 63.55 AMU. So let's write that. So our 1 atom of copper, 1, is 63.55 AMU. AMU stands for atomic mass units. Okay, what about 2 atoms of copper? Well, 2 atoms of copper will be 127.09 AMU. Okay, let's keep going. Let's do 10 atoms of copper. Well, how are we going to get 10? Oh, well, we're going to take 63.55 multiplied by 10. So we're going to get 635.5 AMU. Okay, let's keep going. 1,000 atoms of copper. 1,000 atoms. Wow, that becomes 63,550 AMU. Okay, let's do 1 billion. Let's do 1 billion. So that's 1 with 9 zeros. 1 billion atoms of copper. Wow, that becomes 63 billion 550 million AMUs. That seems like a lot, doesn't it? Okay, let's do 6.022 times 10 to the 23 atoms of copper. How are we going to do that? Well, just like you did before, we take our mass of one atom, 63.55 AMU is 1 atom, times, we're going to put 6.022 times to 10 to the 23rd AMUs. So if we put this number in a calculator and we actually calculate this, this will become 3.827 times 10 to the 25th AMU. And you say, okay, that's a very, very big number, but how much is this? If I hold this amount in my hand, will I feel it? Will I be able to hold it in my hand? Will I need 2 people? Will I need a whole group of people? Will it be as much as a car? Or maybe something very small? Well, we need a conversion factor. So one conversion factor that I'm going to give you today is that 1 AMU equals 1.66 times 10 to the negative 24th gram. That's our conversion factor. And we're going to change the AMUs of my 1 mole of copper atoms into grams. So let's do that. So we're going to say, okay, I had 3.827 times 10 to the 25th AMU. And we're going to use our dimensional analysis. Oops, let's make this nice and straight. We're going to use our dimensional analysis. So we're going to say I have 1.66 times 10 to the negative 24 grams is 1 AMU. And my units nicely cancel out. My AMUs cancel out. I'm going to be left with 63.52 grams. Did this number seem familiar? Did you see this number before? So we have 63.52 grams. 63.52 grams. Wait a minute. This is very similar to this number. Look at that. These 2 numbers are the same, but the units are different. This is why we use the mole. Because when we have one atom is 63.55 AMUs. But 1 mole of atoms, which is 6.022 times 10 to the 23rd power of atoms, is 63.52 grams. AMUs and grams are not the same. They are very far apart. But just like a mole digs from point A to point B, our periodic table can be now seen in 2 different ways, and a mole helps us see it. So let's look at our periodic table. How does this help us? Well, we can look at periodic table on an atomic scale and say that 1 atom of copper is 63.55 AMUs, 1 atom. Or you can say AMUs are too small. I cannot deal with it. In our world, we have scales that use grams. In the back of your chemistry classroom, you probably have a scale that uses grams. We can say, wait a minute. If I have 6.022 times 10 to the 23 atoms, or 1 mole of these atoms, that will be 63.55 grams. And guess what? You can hold 63.55 grams in your hand. You are holding way more atoms than stars in the universe. It's pretty amazing how small atoms are. Well, so let's actually apply that and do something else. Let's figure out how many atoms in a penny. How many copper atoms in a penny? All right, So I have a copper penny in my hand, and I also have a scale. So copper pennies, if you want, this one is pure copper. It's made in 1977. Copper pennies in 1981 are no longer pure copper. So I know I have a copper penny from 1977, so it's a pure copper penny. So it's pure copper. Let's figure out how many atoms of copper am I holding in my hand right now? Well, I'm going to put it on a scale, and I see that my copper penny is 3.1 grams. I have 3.1 grams of copper. Well, what do I know? I know that 1 mole, well, let's write these things down. I know that 1 mole of copper is 63.55 grams. I also know that 1 mole is 6.022 times 10 to the 23 atoms. Okay, so let's use these conversion factors. So 3.1 grams, let's use the conversion factor that uses grams. So that means I have 1 mole of copper is 63.55 grams of copper. And I also know that there is 6.022 times 10 to the 23 atoms of copper in 1 mole of copper. And when I do this and plug these numbers in a calculator, I'm going to get what my calculator says. I'm going to get 2.938 times 10 to the 22nd atoms of copper, but let's use our significant figures. The first number has only 2, so I should report my answer with 2 sig figs. So I have 2.9 times 10 to the 22 atoms of copper. Wow, I'm holding 2.9 times 10 to the 22nd atoms of copper in my hand. The order of magnitude is about the same as the number of stars in the universe. That's pretty incredible. I hope you enjoyed this video and learned something new, and thank you for watching.